Before we begin, if you enjoy stories where humanity surprises the galaxy, hit the like button and subscribe to the channel, because out there in the stars, humans are often underestimated, until they prove everyone wrong. Now let's begin. They fired a plasma shot at the human to test his reflexes. Standard procedure, controlled burst, non-lethal at distance. The scanner was supposed to record a reaction time. It recorded something else entirely, something the lab had never seen before, something that made the chief scientist close the file, reopen it, and stare at the number for 4 minutes without speaking. The Galactic Biological Sciences Institute on Beth Prime had studied 247 species. They had cataloged physiology, mapped nervous systems, documented reflexes, pain thresholds, sensory ranges. They knew what life looked like in most of its configurations. They thought they knew all the major categories: fast-twitch species, high-endurance species, chemical defense species, sensory apex species. Humans fell into none of these cleanly. The preliminary file said, general-purpose organism, no specialized extreme capabilities, moderate across all measured parameters, which was why lead researcher Dr. Voss had agreed, reluctantly, to include a human subject in the Institute's current reflex and threat response study. She needed comparison data, a baseline, something ordinary to measure the extraordinary against. She had gotten the human. She had not anticipated that the human would become the problem. The subject's name was Corporal Deo Mensah, 26 years old, military background, 2 years with Earth's combined forces before being seconded to the Institute's research program. He arrived on a Monday. He filled out the intake forms. He shook hands with Dr. Voss, which was a human greeting custom that she found mildly peculiar. He looked around the research facility with the calm curiosity of someone visiting a new workplace, not nervous, not excited, just present. She showed him to the preparation room. She explained the study parameters. We are measuring threat response reflexes across multiple species. You will be subjected to a series of controlled stimuli. Your physiological responses will be recorded. What kind of stimuli? Sound, light, physical contact, and in the later stages, directed energy discharge. You're going to shoot at me. A controlled plasma discharge at non-lethal range. The purpose is to measure involuntary response time. He thought about it. Okay. She blinked. Okay, yes. You have no questions? Is the plasma non-lethal? At the designated range, yes. Does it hurt? Briefly. The sensation is comparable to a significant thermal contact. Like a burn. A surface burn. Yes. How many times? The protocol calls for 12 exposures over 3 days. Okay, he said again. She looked at him. Most subjects require reassurance at this point in the briefing. About the non-lethal part, yes. You said non-lethal. I believe you. You're a researcher, not an executioner. She looked at him for a moment. You're quite calm. I've been in worse situations. Worse than being shot at in a laboratory. Field deployment. It gets less comfortable than a controlled setting. She made a note. Subject displays unusual threat context calibration. She didn't know yet how significant that note would become. Day 1. The sound reflex tests. Standard procedure. Subject in a sealed chamber. Sound stimulus delivered at random intervals. Response time measured to the millisecond. Most species' reaction times clustered in predictable ranges. Durathi, fast but not exceptional. Well-trained nervous systems. Solani, very fast. Among the best in the study. Vorith, slower, but the response was more forceful when it came. Human baseline in the literature, middle of the pack. Vase expected middle of the pack. She got something else. Mensah's response times were inconsistent. Not randomly inconsistent. Patterned inconsistent. On the first 3 stimuli, his responses were exactly middle of the pack. On stimuli 4 through 8, they were faster. Substantially faster. On stimuli 9 and 10, they were faster still. He was speeding up. Over the course of a test designed to measure consistent baseline performance, the subject was getting faster. Her assistant, a young Solani named Pell, looked at the numbers. His response time improved 22% over the session, Pell said. I can see that. Is that normal for humans? The literature says no. What does the literature say should happen? Fatigue, slight degradation, the same basic pattern across all species we've studied. They both looked at the monitoring screen. Mensa was sitting in the chamber between sessions. He was doing something with his hands. What is he doing? Pell asked. Voss adjusted the camera. He was tapping his fingers. In a specific pattern. Rapid. Controlled. He's practicing his responses, she said, during the break. Between stimuli sets. He's self-training in the middle of a test. She stared. Apparently, she pressed the comm. Corporal Mensa. He looked at the camera. Are you deliberately practicing your reflex responses during the session? A pause. Is that not allowed? It's not. That's not a standard behavior during this protocol. I noticed the sound was coming from a specific speaker array. If I practice anticipating the source direction, I can pre-position my response. You're not supposed to pre-position. We're measuring involuntary response. Oh. He stopped tapping. Sorry, I'll stop. Vase looked at Pell. Pell looked at Vase. He was gaming the test, Pell said. He was optimizing his performance, instinctively, in the middle of a study where we specifically don't want optimized performance. Yes, why? She looked at the monitoring screen, at Mensa sitting quietly, hands still now, waiting for the next stimulus. I don't know, she said. I need to ask him. She went into the chamber. She sat across from him. Why did you do that? She said. The finger practice. Yes. He thought about it, because I could feel my response time improving and I wanted to see how much I could improve it in the time I had. You could feel your response time improving. The gap between hearing the sound and my hand moving was getting shorter. I could feel the gap, so I worked on it. You can subjectively perceive your own response time. Can't everyone? Vase paused. No, she said, not at that level of precision. Huh, she made a note. Is this something you've always done? What? Practice things. Notice physical performance metrics in real time and work to optimize them. He shrugged. I played a lot of sports growing up. You get used to feeling what your body is doing and trying to improve it. Sports. Competitive games. Physical and mental training combined. You said you played a lot. From about age 6, multiple sports. Some overlap. I was competing at a high level by 16. She looked at him. What level? National junior level in 2 disciplines. I didn't make the Olympic squad, but I trained with that group for 2 years. Olympic. Earth's top competitive games. Global scale. You trained at global competitive level. Didn't make the cut for the actual team, but I was close. She looked at her notes. The preliminary file had listed his background as 2 years military service. No noted athletic career. It had not mentioned the sports background. It had not mentioned 16 years of high-level competitive athletic training before the military. Corporal, she said. Yes. Your intake file is incomplete. I just filled out what the form asked. The form asked about military background. Then I answered correctly. It did not ask about pre-military training, history. Then I answered correctly. She looked at him. He looked back. Would you like me to describe my full training history? He asked. Yes, she said. Please. He talked for 40 minutes. She took notes for all of it. By the end, she had a different picture of the subject than she'd started with. 16 years of competitive athletics, multiple disciplines, specific training in reaction sports. Sports designed specifically to push human reflex limits. Then 2 years military. Then the research program. Your reflex training, she said. In competitive sports, what was the focus? Depends on the sport. In my main discipline, combat sport, a lot of it was pattern recognition under pressure, learning to respond before you're consciously aware you've seen the stimulus. Preconscious response. Trained response. The idea is to build patterns so deeply that the nervous system executes them before the analytical brain gets involved. You trained your involuntary responses, yes, deliberately, for 16 years. She set down her notes. That is not typical of the species population. High-level athletes are not typical of the species population. No, but your file presented you as a standard sample. I'm not sure I was described accurately. You were described as a military corporal. I am a military corporal. You are also a 16-year competitive athlete who trained reflexes specifically and deliberately for most of your life. He nodded. That's also true. She looked at the test results from the morning. We need to redo the sound reflex tests, she said, without you optimizing. I can try. Can you? He considered. I can try not to deliberately improve, but if my nervous system does it automatically, that's the data I'm interested in. He nodded. Okay. She stood up. One more question. Yes, you said you can feel the gap between stimulus and response. Yes. In the test session this morning, what did the gap feel like? He thought. It started at about, I don't know the unit, but it felt long, like there was a pause between hearing the sound and deciding to move. And by the end, the pause was almost gone. She was quiet. Almost gone, she said. Not zero, but close. She wrote something. She went back to her lab. She sat down. She looked at the numbers. She thought about what almost gone meant. She thought about the plasma test. She thought about what she was going to record when she ran it. She didn't know yet, but something told her the number was going to be interesting. Day 2. The light reflex tests. Boss ran them without telling Mensa to suppress his responses. She wanted the genuine output. She wanted to see what 16 years of trained response produced. She ran the standard protocol, flash stimulus, randomized timing. Response measured. The number she got was not middle of the pack. It was in the top 10% of all species tested. Top 10% for a species classified as moderate across all parameters. Pell looked at the number. That can't be right, Pell said. Run the calibration. Pell ran the calibration. The equipment was fine. The number was right. Pell looked at it again. This is better than Solani baseline. Yes. Solani are the fastest reflex species in the study. I know. He's faster than Solani baseline. On light stimulus. Yes. How? Foss looked at the chamber where Mensa was waiting patiently. Trained response. He has built reflex patterns so deeply embedded that the gap between stimulus and response is minimal. Can you train to beat Solani genetics? Apparently, in some contexts, yes. Pell looked at the number. I thought training improved performance within species limits. So did I. Are we sure the species limits for humans are what we think they are? She thought about this. No, she said slowly. I don't think we are. Day 3. The plasma test. Voss had spent the previous evening reviewing what she knew about human neurology. She had found several gaps. The Institute's file on human neurology was 4 pages. Most species had 40 to 80-page files. 4 pages meant the initial survey had been cursory. Probable cause. The preliminary assessment that returned moderate across all parameters had led to low research priority. No significant findings expected. Low priority resources allocated. 4-page file. She stood in the observation room. Mensa was in the test chamber. The plasma emitter was calibrated and locked at non-lethal range. Standard protocol, she told Pell. No announcement before discharge. Random interval. Record response time. What are we expecting? She thought about the light reflex number. I don't know, she said. That's the problem. She pressed the chamber comm. Corporal Mensa. We're beginning the directed energy response test. Ready. The discharge will occur at random intervals. No warning. Understood. Any questions before we begin? A pause. Does it feel like a real shot, the plasma? It's a real plasma discharge. Non-lethal at this range. The sensation is a surface thermal event, but the nervous system reads it as a real threat. That's the purpose of the test. Another pause. Okay, he said. Vase looked at Pell. Begin. The first discharge happened at 47 seconds. Standard flash. Short duration. Aimed at the subject's left side, non-vital zone. Response time, measured. The number appeared on Pell's screen. Pell looked at it. He looked at Voss. He looked at the screen again. That's he started. I see it, Voss said. Is the calibration, check it? He checked. Equipment normal. The number was correct. Vase pressed the comm. Corporal Mensa, are you all right? Fine. The first discharge has been recorded. I felt it. Yes. We're going to continue with the remaining 11 discharges. Okay. She released the comm. She looked at the number. She looked at Pell. Run it again, she said. 3 more discharges. Vary the intervals. Vary the approach angle. He ran 3 more. The numbers came back, all in the same range, all showing the same impossible thing. Vey sat down. She was a scientist. She had been a scientist for 30 years. She was very good at not being dramatic about data. She looked at the data. She was dramatic about it anyway. Get Dr. Harith, she said. The neural specialist? Yes. Now. Dr. Harith arrived in 12 minutes. He was a Darathi, senior specialist in neural transmission rates across species. He looked at the numbers. He sat down. He stood back up. He looked at the equipment. He ran his own calibration. He sat down again. This is not possible, he said. The equipment is calibrated. I verified it 3 times. I'm not saying the equipment is wrong. He looked at the numbers. I'm saying this result is not consistent with the known parameters of human neurology. Known parameters based on what sample size? He paused. The standard file. The standard file is 4 pages. He looked at her. 4 pages. Yes. For a species with a complex nervous system. Apparently the preliminary assessment found nothing exceptional and research priority was assigned accordingly. He looked at the numbers again. What's the subject's background? She handed him her notes. He read them. He got to the part about 16 years of competitive athletic training. He stopped reading. He looked up. He trained his reflexes, specifically, for 16 years, at high competitive level, national and near Olympic. Kareth put the notes down. Voss. Yes. What we're measuring here is not baseline human reflex capability. No. We're measuring the output of 16 years of deliberate neural pathway training. Yes. Which means the baseline number in the file is accurate for the untrained population. But the upper limit is somewhere we haven't defined yet. He looked at the numbers. The response time on discharge 3, he said. Yes. That's faster than Solani-trained combat reflex. Yes. Solani who have been trained for their entire adult lives specifically for fast response. Yes. A human who trained for 16 years in a different context is matching them, exceeding them on 2 of the 4 discharges. He picked up the notes again. He put them down again. What is his nervous system doing that the baseline human nervous system isn't doing? That's what I need you to find out. He looked at the chamber. Mensah was still in there, waiting patiently. I need to scan him, Harith said. I'll ask. She asked. He agreed immediately. He sat in the neural scanner for 40 minutes. He sat completely still. He did not fidget. He did not ask how long it would take. He waited the way someone waits who has learned that waiting is a skill. Harith reviewed the scan results in real time. His expression went through several phases. Interested, surprised, confused, interested again. Come look at this, he said to Vyas. She looked. What am I seeing? Neural pathway density. He pointed at specific regions. In the standard human scan in our file, this region is average, standard density for a general-purpose organism. And his? Higher density. Significantly higher. He moved to another region, this area, which is associated with threat response processing. Same thing. Denser pathways, more connections. From training. From 16 years of specific training, yes. He traced the scan. It's not genetic. It's not a species variation. It's developmental. He built this. His brain restructured in response to specific, repeated training demands. Harith sat back. This is neuroplasticity operating over a long time scale. The brain physically reorganized to support the skill he was building. Does that happen in other species? Yes. To varying degrees. But, he hesitated. But what? The degree of reorganization here is unusual. He looked at the scan. I've seen this level of pathway development in very long-term specialists. Solani who've been training their reflex systems for 40, 50 years. He's 26. He started at 6. She looked at the scan. 20 years of neurological development. Starting at a developmental stage when the brain is highly plastic. He paused. Voss. Human children are unusually neuroplastic compared to most species at equivalent developmental stages. Meaning what? Meaning when they start training young, the neurological development is more efficient, more complete. He tapped the scan. He started at 6. He got 20 years of development during a high plasticity window. A window that's longer in humans than in most species. Much longer. Their developmental plasticity extends further into adolescence than ours. She looked at the scan. She looked at the numbers on her screen. She looked at the chamber where Mensa was now eating something he'd brought from his quarters. "We have the wrong data on this species," she said. "We have some of the right data," Harath said. "We have accurate baseline data. We just have no upper range data. Because nobody trained at high level has been studied. Because the preliminary assessment said moderate across all parameters, and nobody looked further." She was quiet. "We need to run the full protocol," she said. "Extended version. Everything we have. That's 4 more days. I know. You'll need to extend his participation." She pressed the comm. "Corporal Mensa." "Yes. We'd like to extend your participation in the study. 4 additional days. Full physiological protocol." "What does that involve?" "Comprehensive scan series. Extended reflex testing. Cognitive response assessment. Physical performance battery. More plasma shots? Some, yes." A pause. "Can I get better meals? The cafeteria options are limited." Vase blinked. Yes, I can arrange that." "Then okay." Hiraeth made a sound. Vase looked at him. He was trying not to laugh. "He negotiated better food," he said. "Yes. In exchange for agreeing to be shot at more." "Yes. That's very human," she said. "Apparently. 4 more days." Vase ran everything. Every test she had. Menzel went through the protocol with the same calm steadiness. He didn't complain. He didn't refuse anything. He also kept trying to optimize his performance on every test, which Vase eventually stopped fighting and started documenting. The cognitive response assessments were where things got genuinely strange. The test was simple. A series of pattern recognition tasks under time pressure, randomized. Increasing complexity. Boss expected the standard performance curve. Start strong, degrade with complexity, plateau. Mensa started strong. He did not degrade. He got faster as the patterns got more complex. "He's doing it again," Pell said. "The optimization. In real time." "Yes. Can you get him to stop?" "I've tried." "Can't he control it?" She pressed the comm. "Corporal Mensa." "Yes. You're optimizing again." "I know. I'm trying not to." "What's happening?" A pause. "The patterns have internal logic. Once I see the logic, I can't unsee it. My brain just runs it. You can't turn that off. Not easily. It's like, once the pattern is there, the response becomes automatic. Your brain automated a skill you learned." "I guess so. I've been doing it long enough." She closed the comm. She looked at Pell. "Pattern recognition," she said. "Another trained skill. He's been doing it since 20 years, in sports, reading opponent movements, reading game state, pattern matching under time pressure." She looked at the numbers. He automated it. His brain runs it without conscious input now. "Yes." She looked at the test. "Which means the test isn't measuring his maximum, it's measuring his floor." Pell stared. His floor. The automatic baseline. What happens with no effort? Then his ceiling is, I don't know. She looked at the monitor. We'd need to know what happens when he applies conscious effort on top of the automatic response. She pressed the comm. "Corporal Mensa." "Yes. I'd like you to try something." "Okay. Instead of trying to suppress the optimization, I'd like you to lean into it. Actively try to perform as well as you possibly can." "You want me to try?" "Yes." "Before I was trying not to try." "Correct. So now you want maximum effort?" "Yes." A pause. "That's going to be a different number." "I know. Significantly different. I'm counting on it." The numbers came back. Vase looked at them. She didn't say anything for a while. She saved the file. She closed it. She reopened it. She read the numbers again. Pell leaned over. He read them. He sat back in his chair. He put his hands on his knees. He stared at the ceiling for a moment. "That's the top of the whole study," he said. "Yes. Not just humans. No. Of every species in the 247 species study. Yes. That's the highest cognitive response score in the history of this program. Yes. He's a corporal. Yes. Not even a specialist. No. In a field where he applied maximum effort. which he apparently had not been applying previously. Pell looked at the numbers. What does maximum effort mean for the species generally? Bosch thought about it. I don't know. I have one data point. One data point that's the highest in the study. Yes. From a species we rated moderate. Yes. Because we tested the average. She looked at the file. Had 4 pages of neurology notes that turned out to be the beginning of a much longer story. Because we tested the average, she said. She called Mensa in on the final day, not for a test, just to talk. He sat across from her. He looked rested. Better meals apparently helped. I want to ask you some questions, she said. Sure, not for the study record, just for my understanding. Okay. You've been doing what I asked. You've been cooperative, patient. You sat in a scanner for hours. You've been shot at 12 times. 14 times. There were 2 extra sessions. Right. She looked at him. Why? Why what? Why cooperate so completely? This can't be comfortable. He thought about it. It's interesting. The research? Being studied. Knowing someone is trying to understand how I work. He shrugged. That's interesting to me. Most subjects don't feel that way. I'm curious about the results. You want to know what we found? Yes, she looked at her files. She thought about the numbers, about the neural scan, about the plasma response time, about the cognitive assessment ceiling. What do you think we found? She asked. He considered this seriously. I think you found something you didn't expect. Why do you think that? Because on day 3, after the first plasma test, you brought in another researcher. You don't do that for expected results. She looked at him. You noticed that. Harith, senior neural specialist. You brought him in because you needed a second opinion on something that didn't fit your model. Yes. What didn't fit? She hesitated. The response time, she said. How fast? She told him. He was quiet for a moment. Is that good? It's exceptional, by any metric in this study. Better than expected. Better than I thought your species could produce. He was quiet again. But I trained for 20 years. Yes. So it's not a species thing. It's a training thing. The training is enabled by specific species characteristics, the neuroplasticity, the developmental window, the capacity to automate learned responses. She looked at him. The training is yours, but the hardware that made the training possible, that's human. He looked at his hands. We do train a lot, he said. How early does it start typically? Depends. Competitive sports, parents start kids at 4, 5, 6. Some earlier. If you're serious about a discipline, you're training consistently from childhood. That's typical? For athletes, yes. What percentage of your species would you say trains in some competitive discipline from early childhood, he thought. Honestly, a significant percentage. Sport is culturally central. Almost everyone plays something at some level, even if not at your level. Even at casual level, you're building pattern recognition, physical coordination, competitive response. He paused. The species as a whole trains more than maybe the file suggests. She made a note. Corporal Mensa. Yes. The file on your species, the one that rated you moderate across all parameters. What about it? I'm going to have to rewrite significant portions of it. He looked at her. What will it say? She thought about the numbers. About the ceiling sheet found on the cognitive test. About Harat's face when he saw the neural scan. About the plasma response time that had made her close the file and stare at the wall. It will say, she said slowly, that the moderate baseline is accurate for the unstrained population. And that the developmental ceiling for trained individuals is significantly underreported. How significantly? I don't have enough data points to be certain. Best guess. She looked at him. I think you're a species that looks ordinary until you decide to be extraordinary. And then you become extraordinary at a rate and to a degree that our models don't predict. He looked at her. Is that in scientific language? It will be in the paper. What does the scientific language say? She turned her screen toward him. He read the summary line she'd written. It said, human neuroplasticity combined with early developmental training produces performance characteristics significantly above species baseline projections. Upper range capability is poorly defined and requires comprehensive additional study. He read it twice. Poorly defined, he said. We don't have the ceiling. What does that mean in practical terms? It means we don't know how good you can get. She looked at him. We know how good the average is. We don't know where the top is. He was quiet for a moment. I can tell you where the top is, he said. Where? Wherever the best trained person has gotten to so far. He looked at his hands, and then a little past that. Because someone's always training. She looked at him. Always. Someone's always working on getting better. That's what sport does. You set a record. Someone else trains to beat it. The record moves. The ceiling moves. She wrote something. She looked at it. She added something. She looked at it. She added something. You said earlier you didn't make the Olympic squad, right? So you are not the best trained human in your primary discipline. No, not even close. The people who made the team are better than me. She looked at the numbers. The highest cognitive response score in the 247 species study, from a person who was not the best at what he did, not even close. She sat with that for a moment. Corporal, she said, yes. Do you know what the best Olympic athletes in your discipline would score on our cognitive assessment? He thought about it. No. Neither do I, she said. Is that a problem? It's a gap in the research. A significant gap? She looked at her screen. She looked at the number. She looked at the notation, highest in study. She thought about the ceiling that kept moving. About someone always training. About 20 years of early window neuroplasticity producing a number that broke her model. And that person wasn't even the best at their sport. Yes, she said. Very significant. The paper came out 6 months later. 43 pages. Vase and Harith as co-authors. Title: Neuroplastic Development and Performance Ceiling Revision. A case study in human motor and cognitive reflex systems. The abstract's final line read, current galactic species performance classifications for Homo sapiens are based on population mean data gathered from unstrained individuals. This study presents evidence that trained human performance characteristics differ substantially from these means, and that the developmental mechanisms enabling this divergence, specifically extended neuroplasticity and early-stage automated response training, represent a species advantage not captured in current literature. Upper-range human performance metrics remain undefined. Further study is recommended as a matter of scientific priority. It was read by 300 researchers in the first week. By the end of the month, it had been accessed 4,000 times. It was flagged by 5 different military intelligence divisions. 3 of them immediately commissioned their own studies. Dr. Juing Harith was invited to present at the Galactic Biology Symposium. He used, as his centerpiece piece of evidence, a single graph. The graph showed reflex response time for every species in the original study. There was a cluster of dots representing each species' range. All the species, all their ranges, visible as a shape, and then, off to the left side of the graph, 1 dot. Just one. Outside the main cluster. Outside the expected range. A human. The fastest in the study. Not the best trained human that had ever lived. Not an elite. Not a champion. Just a corporal. Who had been doing this since he was 6. Harith stood at the podium. 300 scientists in the room. He looked at the graph. He looked at the audience. The dot on the left, he said, is not an outlier. He paused. It is a preview. Somewhere on Earth, in a gym at 6 in the morning, a 17-year-old was training. She didn't know about the study. She didn't know about the graph. She didn't know that a number from her nervous system, the nervous system she had been systematically improving since she was 5, was going to break someone's model someday. She was just training, because tomorrow's session would be harder than today's, and she wanted to be ready. And that's the story of how one human changed what the galaxy believed was possible. If this story moved you, leave a like on the video and tell me in the comments where you're watching from. And if you enjoy stories where humanity refuses to give up, subscribe for more HFY Sci-Fi stories. Because out there in the stars, humans are just getting started.